Hello everyone, in this project I'll walk you through how I built a machine learning model to predict the hourly energy output of a combined cycle plant. We look at the database, my modeling approach, model performance and final thoughts. The problem definition. So in this, the task was the predict the hourly energy output. The features were temperature, ambient pressure, relative humidity, exhaust vacuum. The target was the energy output, which is PE and megavolts. The approach was regression. So the database contains 9,568 hourly records from a combined cycle power plant. The features include temperature, ambient pressure, relative humidity, and exhaust vacuum. The target we wanted to predict is the net hourly output measured in megawatts. Since the output is continuous, this is a regression problem. Now, features and targets and modeling approach. So the matrix over here we used was the RMSE, which is the root mean squared error. Now the model tried was the linear regression baseline, the random forest, the non-linear. The data was split into two, which was 80% training and 20% test. During each iteration, the validation was cross validation. My evaluation matrix was RMSE since it penalizes large errors and it is easy to interrupt in megawatts. I tried two algorithms, linear regression and simple baseline and random forest, to capture more complex relationships. I split the database into, again, 80% training and 20% testing, and used the cross validation to compare models. Now, model approach and performance. Now, this result showed that the linear regression achieved an RMSE of 1.53 megawatts with an R2 of 0.97, while the random forest achieved an RMSE of 1.66 megawatts and R2 of 0.96. In this case, the linear regression actually performed slightly better, so I selected it as my final model. Now, modeling approach. So looking at the features importance from the random forest model, we see that the temperature has the largest effect on output, followed by an exhaust vacuum and relative humidity. Ambient pressure had only a minor impact. This makes sense as the higher temperature typically reduces the plant efficiency. So you can see that the training process, evaluation matrix and the features importance chart generated from the random forest. Now the training results and features are the important. Now to conclude, predicting power plant output is a regression problem. Both models performed well, but linear regression was slightly stronger here. The analysis showed that the temperature is the most critical feature affecting plant efficiency. My model achieved an RMSE of 1.5 megawatts and R achieved 0.97, which indicates strong predictive accuracy. The model interruption and insights, interpretation and insights. Temperature and exhaust vacuum are most influential. Random forest captures non-linear relationship better. Relative tools for optimizing plant energy and output predictions. Thank you. That was my project.